Industry 4.0, manufacturing as a service, generative AI at the edge, software-defined everything. Those are new terminologies that is being introduced to the manufacturing space over the past 2 years, and they only translate to innovation. Innovation and leveraging the power of data. I'm May Mohammed. I'm the head of manufacturing, automotive, and chemical industry solution architecture team here at Germany. And together with Timo from Kasha, product owner, Marius, the head of global outbound excellence in Amazon, together we will take you through the journey of innovation, 2 types of innovation actually, product innovation and process innovation. All right. The manufacturing industry, of course, if you know it well, it's quite complex. It consists of multiple sub-industries, from discrete manufacturing, like automotive, aerospace, and electronics, to process manufacturing, like chemicals, steel production, agriculture, and more. Each of those industries are working feverishly on their transformation journey. To take example of the automotive, there are key stakeholders that sees the future of mobility to be more sustainable, safer, and customer-centric than ever. Looking into the agriculture, for instance, there are multiple teams, actually thousands of teams across the globe, working on feeding the world in more responsible and sustainable ways, focusing on farming, efficiency, and most importantly, connectivity, connecting farming operations to market, and most importantly, end users. Although that they have a lot of expertise in the manufacturing industry, some of these industries and companies has been there for more than 100 years. And they have been innovating on behalf of their customers to make sure that they deliver what they demand for years and years. Yet, as they look to transform, they still see barriers with one need of change. And the change is driven from data. All right. Data. At AWS, our vision is to support those customers, to support those key stakeholders, the world leaders at manufacturing, to achieve their transformation vision, be it on mobility, aerospace, steel production, supply chain, regardless of what that may be. Our vision at AWS is to help them and enable them, bringing mobility, services, operations, products faster to the world. And how we do it faster is basically leveraging the data. The manufacturing industry, it's no secret, the advanced technologies and the business technologies over the past decade, especially the past 5 years, is really driving a lot of data generation. In fact, the manufacturing industry is twice as the biggest industries in the space. So if we're looking into media, entertainment, financial services, whatever the industries are, the manufacturing industry is producing twice as much data as opposed to the rest of the industries. And the more data the manufacturing industry produce, the more challenges it gets to get the best out of this data. In fact, IDC forecasts expect that by the end of 2025, there will be more than 55 billion devices connected as IoT. And of course, the more IoT devices to be connected, the more those numbers will be growing. Which gets me to the next point. This gigantic amount of data, we're talking about 80 zettabyte of data. And if you had asked me what zettabyte mean, I only know one thing: it's huge. And as we look to the transformation of the different manufacturers to be real time, they need to be able to leverage this data, which requires an incredible amount of compute power, managing, storing, differentiating the kind of data that they have, which lead me to the generative AI and the different AI capabilities. At AWS, since we envision the future full of data, we believe in the capabilities of technologies like AI, machine learning, and generative AI to help those customers in their transformation journey without the need of army of data scientists, without the need of that much of expertise for machine learning, so that they can still focus on their real manufacturing challenges, engineering and design and supply chain challenges, while still being able to compete in the future of the manufacturer, which is basically defined by data. Those manufacturers are trying to adapt to the shifting customer needs, the fast decision-making that has to be driven, sometimes even real-time. The business agility, which is more than just a word, it's just adapting to the great variations happening on the multi-layer supply chains, when the weather changes, when you have a strike in airports or whatever, they need to be able to make decisions to serve the customer best. So what are your challenges from getting the best out of your data and the insights as a manufacturer whose core business is manufacturing? First of all, the siloed data, the fragmented data, the commodity prices, the cost that comes with it is adding a lot of pressure on the manufacturers. And most importantly, the trend of software-defined everything is becoming a real differentiator for manufacturers. The manufacturers of today and the next generation of manufacturers needs to be able to meet their customer expectations, not only meet, exceed their customer expectations, and this is driven by data. And of course, the software-defined promise is becoming really key differentiator between the different manufacturers, be it buyer, household appliances, manufacturer of aircraft engines. Every single user now wants to have a software-defined features that can give them the control and the ability to understand their software and the products. At AWS, we have been collaborated and committed to invest in a wide variety of partners that is only focused on industry-specific use cases and solutions to provide the best innovation possible for our customers. We have been serving thousands of customers, enterprise, medium, and even startup for manufacturing over the years, where we work with them as strategic partner in order to transform the manufacturing industry into data-driven and software-driven everything. All right, those are the key innovations that we are focusing on. So products innovation, process innovation, and today I would like to ask Timo to come and tell us more about the Kersha journey to the cloud.
In the beginning, I want to give you an introduction to the company Kartra and their journey into the cloud. So the impressive journey Kartra did the last 12 years. After that, we will have a deep dive into robotics and IoT, and in the end, we will wrap it up. So a quick question to you as the audience: who already knows Kartra? So I was kind of expecting that, and due to the fact that many of you already know the company, I will just do a short introduction. So Kartra was founded in the year 1935. It's a manufacturer of cleaning devices and cleaning solutions, and was founded by the two of them here. So as you can see, Alfred Kartra and his wife Irene Kartra. So the company is still family-owned in the third generation. So there's still DNA of the family in the company by being really innovative and constantly working on new products and business models. The company itself operates in more than 70 countries around the world with more than 15,000 employees. Kartra has a purpose as well as a goal of creating a sustainable environment and making the life of the people easier with efficient and innovative cleaning solutions. With that said, let's have a look at Kartra's journey into the cloud. And when talking about the move into the cloud, we need to go back a long time ago, when in Germany was no AWS region available and people used to use e-commerce more often. At that point in time, Kartra noticed that they are not really able to provide a great customer experience when it comes to selling their products online due to the high traffic on their website and e-commerce shop. So in 2012, Kartra was looking for a technology to provide a great customer experience and to scale globally. And AWS exactly provided this technology at that point in time. And that was the reason why both applications, the website and the e-commerce shop, were migrated to AWS. Only 1 year later, all of the professional devices were connected to AWS using an IoT gateway in order to give customers insights into their data, for instance, where the device is located or what the health status of the device is. In addition to that, the data was used to get further insights how the products are used. In the year 2016, a global cloud-first strategy was decided on, with the intention to get rid of the data centers. New applications from then onwards were naturally built within the cloud. And then 4 years later, in the year 2020, a bigger migration of all on-premise non-SAP applications was decided on. So there was a really tough timeline because Kartra needed to move out of a co-location. So approximately 120 applications needed to be migrated to AWS within only 7 months. This was a huge effort, and a lot of re-architecture and cleanup needed to be done at that point. But it was definitely worth the effort because it reduced the costs of those applications by approximately 20%. What is interesting, and what you can also see on this timeline over the last years, is that Kartra started to grow together with AWS from one account in the beginning, in 2012, to where they are at the moment. Because now, Kartra is in the final steps to migrate all SAP systems to AWS. With that, Kartra has then around 90% of their applications running within the cloud. Without the collaboration with Zoe as a development partner from the beginning onwards, along the whole cloud journey, this would not have been possible. So Zoe supports here in scaling globally and getting the knowledge and the talents about AWS and the cloud. So with the cloud journey having in mind, let's have a look at the history of Kartra when it comes to developing robots. As you can see on the left, Kartra already started in the year 2002 with the first robot vacuum cleaner. And what is interesting is that at that point in time, even though they were early on the market, the device was not sold that often. And you might know the reason, because there was no connectivity at that point, so no scheduling was possible, nor the cleaned areas of the device could have been seen on a dashboard. So there was no real value for the customer, and that was the reason why Kartra stopped again developing robots. About 10 years later, competitors then came into the market and sold many of those robots. And what was the reason for this success? It was the connectivity. Because at that point in time, mobile applications were established and the devices were connected. Then, in the year 2017, Kartra started again developing robots using AWS IoT and developed a successful product. So in the end, in that market and for Kartra, it is all about the connectivity, gathering data, and controlling devices. Nowadays, Kartra has many different connected products in the consumer area, as you can see on the left as well as on the right, and in the professional area, as you can see in the middle. By that, Karcher is able to gather a lot of
Hi, my name is Kira B50, and I'm looking for a home. When most people have already finished work, I clean big halls, narrow aisles and corridors or irregularly shaped warehouses. I'm always ready to go. I prefer to clean early in the morning or late at night, fully autonomously. When I run out of energy, I recharge my batteries at the docking station and exchange the water. I am also very maneuverable and agile. I whiz over the dirty ground with my powerful roller brushes. Well, I must confess, I am a cleaning fanatic. I even clean right up to the wall. Nobody is perfect. Interested? Get to know me. The first fully autonomous scrubber dryer from Karcher.
So this robot, the Kira B50, works the same way as the ones you might have at home, so it knows where and when to clean. And cleaning routes can be seen and also created on a dashboard. But this is the next generation of connected products. So Karcher already knew that what is working in the consumer area, that you just buy a device as a consumer and then it cleans autonomously, that this also needs to be introduced to the enterprise customers. And as you can see now, when it drives by, the device has more than 10 cameras and 2 LiDAR sensors. So there's a lot of electronics, but a lot more IT in it. The user interface is a web interface and not an usual Qt interface anymore. And this also demonstrates and underlines how the development of such a product changes the culture of a company due to the different approach on how such a robot is developed and then also shipped to the customer. And this is one important aspect where also AWS supported Karcher, for instance, by executing firmware updates remotely. Because when it comes to those firmware updates for regular DevOps processes, the shipment of those firmware updates need to be stable. And this is also the reason why we used AWS AppSync for the architecture for developing the Kira B50. With the firmware updates, it's then possible that new features can be released and also that the customer gets the features which are desired and needed for the specific use cases. So for the development of the Kira B50, there were really a lot of challenges to solve, especially when this is the first industrial robot you're working on. So in fact, the complete process of developing a robot changed from just selling a device to the customer once to accompanying the customer during the whole product lifetime. And this is again the point where firmware updates play an important role. In addition to that, by using many AWS serverless services, a modern and cost-efficient architecture was set up.
And is it enough, Timo, just to be connected to the cloud? Let me just take you through the software-defined everything, and we will get back to Timo and the Karcher story. We are a working backward company, so basically we work backward from the customer needs. As a household wife, I need to see my dishwasher when it's done because I want to load it again. I want to make sure that my stove filters are changed properly so I don't have issues with the product. As a factory and plant manager, I want to know if I have a spare part that is missing and I need to backfill it. I want to know if I have a maintenance window that is not going to be met because whatever is needed and I need to be able to order it and ship it. I want to be able to manage my inventory. If I am a warehouse, I want to make sure that I don't pay that much of cost at ground. So regardless whether you are a B2B, a B2C, or just a wonderful kid who wants to have a connected bicycle that he can know when to do maintenance and where to charge, you need to be able to connect it. The manufacturing is a data-rich environment, and the promise of a software-defined everything is no longer a dream or a vision. It's something that is happening, and it will transform the manufacturing industry as we know it. Actually, it is transforming it at a pace never seen before. Back to my question to you, Timo. Is it enough to be connected to the cloud?
So when answering that question, I would say no, because there are some other aspects we need to consider here and which are really beneficial for a company. Let me bring a few examples here. So the first one is in the context of component right-sizing. So by gathering the data, we were able to better understand the customer, and especially for the professional devices, we noticed that the battery was used in a different way and less than Karcher thought and designed it. And that was the reason why the component of battery was designed and adjusted to the customer's needs. A second point for which the connectivity is really important is the aspect of predictive maintenance. Because one aspect here is, or one example, is that we are using noise sensors, and with that, Karcher was able to learn when a brush gets broken. Because when this happens, then the brush points out a different curve of acoustic, and then the brush can already send to the customer in advance in order to avoid downtime of the device. The third example I wanted to bring here with me, or advantage of the connectivity, is firmware updates. So you can imagine the development of a product like the Kira B50 never really stops, and therefore firmware updates play an important role. And specifically for the firmware updates, there are two examples which need to underline this. The first one I brought with is that the customers came up during the use of the Kira with the desire to have more than one home station for the Kira to charge or also to upload the dirty water. By adding this feature to the firmware and updating the device, the Kira was enabled to use more than one home station and was therefore able to clean even larger areas. And as a result, the customer requirement was fulfilled. And the second aspect I want to mention here is that the companies came up with the requirement that the Kira also interacts with its environment. So, for instance, to send a signal to the building control system to open the fire door, because then the Kira can pass by, do the cleaning job, and then closes the fire door again. And this is also only possible with a scalable infrastructure, which is also open to connect with its environment. And this is exactly what AWS provided us for that case. And the last point I want to mention here is the visibility after point of sale. And to be honest, this is one aspect where the organization needed to adopt, because in the old days, a device was sold with a service contract, and but now with the robots, if there comes an issue up, then you cannot wait until many days, but you need to fix it as soon as possible. And the change needed to take place because the whole workforce in the queue from the device to the connectivity and the cloud needed to understand and find the issue in order to solve it. So what's around the corner and what is going to come? So there's definitely a lot more to come. Because with the data that is collected, the features can be further improved and new devices will be developed. In addition to that, there will definitely be new robots in the professional area, like, for instance, vacuum cleaner, bigger ones. And especially for the device you just seen driving through this hall, the Kira will also in the future not only communicate with the facility management as the building control system, but also with other Kiras. So the whole ecosystem will be connected to each other. By that, for instance, one device can send that the cleaning job was finished, and then the Kira can start with it. And this is especially important when there are dependencies between the devices, and therefore communication is needed.
Thank you very much, Timo. Quite inspiring innovation story using IoT and different capabilities of AWS. Prior to just moving to the wonderful story of Amazon and how they are using AWS technology for process innovation, it's also worth mentioning that those manufacturers, as previously mentioned within this session, as they look to transform, they are really trying to build new service models around those software-defined features that we just talked about. To look into storages, compute, and capabilities is not only that, but also to modernize their current landscape and make sure that they are building software that can be upgraded, that can accommodate new features, real-time, working backward from their customer demand. With that being said, I want to hand over to Marius now to talk to us about the next innovation story with Process.
Thank you. And thank you, Timo. Thank you, May. Really impressive story from Kirche, that how you went through, and also interesting to see what's possible in product innovation together with AWS. I'm talking about a different side of the business in operations, which is processes. You probably all heard when you worked with manufacturing that you need a standard. You need a standard operating procedure. And the difficulty here is, how can you make sure that this standard is followed through when you work with people? And how can you make sure that your technical solutions support you in achieving that when you need to scale fast in an environment that's constantly changing? This is the environment that we are in and that we need to compete with. Before jumping into it, I want to start with a quote from Jeff. He shared that he frequently gets asked the question, what's going to change in the next 10 years? Of course, it's a very interesting question, but it's also one that is very hard to answer, and even harder to answer correctly. So he said the more interesting question that gives us focus is, what's not going to change? And we put 3 things as our daily focus that help us in a fast-paced and changing environment to know what kind of decisions we need to make. And the first thing is, what didn't change over the past 10 years and won't change in the future is cost. You probably never see a customer go to a car dealership and say, let me give you €1,000 more for that car. You try to bargain. You try to make a good deal, right? The next thing is quality. If you see a scratch on the car, you complain. You don't want any scratches on your new car. You want it nice and clean. Same for services. If you pay for a service, it should function. And the last thing that's not going to change is the speed. We often are asked, why are you so eager to be faster and faster, go from 2 days delivery to next day delivery? And we see that the customers are interested in it. The sales numbers speak a different language than what we sometimes hear. If we are able to offer your product faster, we see more sales. And the same applies if you go to a car dealership, you want to drive out with your car right away. You want to feed it, you want to experience it. Same with the goods that we are selling. Now, who has ordered something on Amazon before? Okay, maybe I should have asked the other way around, but good to see so many customers. The thing is, you probably ask yourself why I'm on stage with May and why are we working with the manufacturing experts in her team when we are most known for being a retail company. To give you a better understanding of what kind of business we are operating in, I brought a short video.
Welcome to your Amazon Future Engineer Fulfillment Center tour. My name is Trinidad, and today I'm going to be your guide on an adventure into the big world of computer science and robotics. So let's go take a look inside. Here at Amazon, people and robots make an amazing team, working together to pick, pack, and ship items to our customers as safely and efficiently as possible. Behind me, you'll see some of our robotic drive units in action, which house some of the millions of items that we carry on our website. Now that those items have been picked off of our pods by our Robot Picker Wonder team, it's time to get the items into their famous Smile boxes. SLAM is where we carry out quality control and where each customer order gets its address label. Now that we've seen how we pick, pack, and address our customer orders, we're here in the shipping area to witness the final step that gets the boxes from the truck to your doorstep. Don't forget to keep studying computer science and engineering. You just might be our coworker one day. Well, that was a blast. Thanks for joining us, and we can't wait to see you on a future FC tour.
So this was a glimpse into the outbound operations in our fulfillment centers. And when we look at the operational network that we work in, we separate into first mile, middle mile, and last mile. The first mile are our fulfillment centers. That's where my team focuses on. The middle mile is where we try to reduce the number of trucks on the road. If we have goods from, let's say, Hamburg and Berlin going to the south of Germany, we don't want 2 trucks to take the full route. We have a sort center in Hanover, and then we merge the volume and have 1 truck going to the destination city. And then we have the last mile, where we have delivery stations closer to the city, where we take the goods from the trucks and map it onto routes, put it on the Sprinter vans, and deliver it to your doorstep. To give you some numbers of what kind of challenge we faced in terms of scaling, 24 years ago there were 2 fulfillment centers, one on the East Coast and one on the West Coast. At that time, that was deemed sufficient to supply the network. By now, we have 370 fulfillment centers across US and Europe. We have expanded as well to Japan, Australia, Singapore, and many other countries. Each of these buildings have roughly a headcount of 2,000 people, and you've seen multiple scan points per package. Our middle mile is a little bit smaller. We have 120 sites in US and EU, and the last mile deliveries have around 650 delivery stations in those regions. That means when we look at tech support, we need to not only look at having it in one building, we need to be fast, adapt to the changing environment, because the robots that you're seeing here in that video, they were not there even when I started. Back then, we had shelves, we walked through them, we picked the units ourselves. So the process changed constantly, and when we have a change, we need to scale it to the full network, around 370 buildings, fast as well. So when we look at the Amazon retail page, the thing that is coming from us is that promise. So when you order something, you see that this changes, and it's saying you order in the next 2 hours or so. This is connected in real time to the state of the network. What kind of possibilities do we have to deliver to you? And it changes constantly. It updates if we have an emergency in one of our areas and make sure that it is 100% promise that we can keep. Once you order, this cannot be changed, and it's sacred to us to keep that promise for every shipment. Because my team sees their success in your ability to have a good night's sleep, even if you forgot to order the present for your kid on the next day. If this says it's going to deliver tomorrow, then you don't worry. That's when we say, okay, we were successful. Last year, we shipped around 15 billion packages, each with individual scan points, and we need to make sure that we can track every scan point of those. May mentioned the large amount of data that we have to analyze, compute, and work with. This is only possible for us by working with the AWS manufacturing team. And every building that we have operates at a peak of 35,000 shipments per hour. So even the slightest mistake can have an immense impact onto our customer. And even a pallet misplaced and forgotten to load is 500 to 600 customers impacted right away. So when we talk about making sure that every process step is followed, we need to make sure that we can track it and then we can proactively make sure it's going through. And the target for our fulfillment centers is 99.8% of orders need to be delivered on time. And we're currently trending above that. How are we able to achieve that? We have worked with May and her team to structure into 4 management systems and built that on our platform Skynet. The first is very classic insights and actions management system. We look, or the frontline leadership has the ability to look into the past, what kind of defects did we have, where did we have delays, and define the best actions to avoid them. Now we have the process deviation management system. So every process step we track, and the areas where we see high risk, we can alert the frontline leadership in real time if the process is not followed through as required, and make sure that we don't only look reactively, but we are able to proactively avoid any customer impact. The engagement management system is something where we look into how can we make sure that the defects that are generated are reduced overall. If we have new hires, we need to make sure that they understand what are the key aspects of their process as fast as possible. If we launch a new building, the first day we hire 600 people, and these need to be trained in the processes right away, because otherwise the customer is impacted. And the last one is our master data management system, where we bring together all the relevant information from the different nodes and make sure that we have multiple paths to the customer constantly. And if one node is down, we immediately update and make sure that we have other fallback opportunities to still meet the customer promise. But to give you some examples, the first thing that we looked into was how can we give our frontline leadership more time to look into defects and to enable a zero defect mentality. One thing that we found out is they spend a lot of time analyzing the past. They look into metrics that are day -3, day -4 old, because we wait for the customer impact to see, okay, this actually was delayed to the customer, now we look into what happened. That's the first thing that we tackled and said, okay, let's look at projection of what will have a customer impact and look at these defects the next day. The other piece is that our frontline leadership had to switch between different kind of dashboard solutions, different kind of data sources, and find and put together the data that they need to define the best actions to avoid this from reoccurring, this defect. So we looked into how can we provide the most relevant information to the operators in the right form. So if they open the next day, they don't need to go to a dashboard. They will be told this is what you need to look into. These are the defects from yesterday. And this is the relevant data, how we define that this is a defect, and what occurred, where did the scan point fail, what happened. All of this is in one place. And the last piece was that often you need the operator's input. And running 3 shifts, it might be difficult to find the person in the night shift that maybe is the next day off, and then you delay your root causing and you delay your understanding of the defect. So we said, okay, let's be even more closer to the defect, and as soon as we see a scan point or a defect happening with a high projection of a customer impact, we alert the frontline leadership, we make them aware of it, and we ask them in a simple text field, please enter what was the issue. Doesn't need to be any fancy input. You can just type it down, because at the end of the day, our large language model, supported by Bedrock, is helping us to summarize what occurred in that day throughout the 3 shifts. So the operator that looks into the defects from the day before has an overview of the relevant data and a summary, nice and neat, on what are the defects or inputs from the operators throughout those shifts. This gave us a lot of opportunity and time back for the people running the business. And the next example is something within our ShipDock area. I shared earlier, one pallet has 500 to 600 customer orders in it. So we need to make sure that every process step with a pallet is 100% accurate, because it's also the last time that we have a manual touch on it. Once it's on a truck and the truck door is closed, it's very hard to change it. Nearly impossible. So we need to make sure that every process step, every scan, if I move a pallet from this location to another location, I need to scan a barcode. These barcode scans I need to track and in real time be able to say, okay, this is something that might be a risk and alert the supervisor to make sure, hey, please look into these defects because they might impact the customer. We have an escalation part. If a lot of these ones are not tackled on time, it goes up and up and up to make sure that we are not going into a situation where the next day we look into it and say, oh, look, we had all these alerts, we didn't action up on them, now we need to train someone. When we started, a lot was about making sure that the operators are trained and knowledgeable of the process steps and are able to follow them. We wanted to get rid of this because it's very hard to track and make sure that every operator is always at the best knowledge of the process. So we implemented a process deviation to any defect that is occurring. For example, if I'm operating with a pallet and the next scan is on a staging location where it waits for the truck to arrive, this scan is missing, then we alert after 2 minutes the supervisor to check where this pallet is, because otherwise we're not going to find it. Then we track how fast are we in fixing these defects and make sure that our operators are looking into it. And the last piece of this one is, in the insights and actions I showed earlier, we provide data to help identify what the error was. But with these alerts, we already know what the error was. If they were not followed through, we don't need someone to look into and define, oh, look, this scan point was missing, then they did not look into it. And maybe something happened, maybe there was an accident and they couldn't look into it. All this data, we have it, and we can say, these were the alerts that were not actioned upon. This is the comment from the operators in the shift saying they had an accident and they couldn't look into it. So the root causing is done in 2 minutes, when in the past it took 2 hours. And of course, any process deviation we look into, we make sure that the onboarding for new hires is also up to date with these risks. But the problem for us, or the challenge why we started working with AWS was, okay, the processes change. We picked units from shelves, now we have robots. We are introducing robots in our ShipDock as well. Everything changes constantly. So we need to quickly adapt. The way we are loading trucks changes. We're implementing milk runs. We're implementing trader hands-off. All of these processes, they're constantly piloting. And if they're successful, our partner teams want to roll them out globally as fast as possible. So we need to make sure that we can keep up with that speed. And this is, when we look at a solution, this is all that you need. You need someone to build the front end. You need someone to build the back end. You need networking. You need authentication. All of that needs resources and time. We were able to leverage all of the services. I mean, I think it's widely known that Amazon EC2 and S3 help you to outsource compute and storage. But the other services help you to reduce your developing resources and to adapt and develop faster. So to summarize, the main challenges for us is to scale. So if we have a successful pilot of a new way of loading traders, we need to make sure that when the region is successful, this is going live within a couple of weeks for global. So our tech solution needs to adapt and be able to scale on all the 370 sites within a matter of weeks. When I started, we targeted a month per country to keep them up to date and make sure that all the necessary tech support is available. We are now down to 1 week for a global launch. When we look into defects, we need to go from reactively analyzing what happened to proactively knowing this will have a customer impact, and then be able to avoid the customer impact in the first place. And the last thing is we need to speed up our development, because the process and the environment that we're working on constantly changes. When I started, we had an intake process. It took about 6 months for a solution to be developed. When the developers came in with a new solution, it was like, okay, we don't have that process anymore. So now we're down to 1 month being able to deliver a technical solution supporting the operations. And this is possible for us by working with AWS and May's team. So thank you.
Thank you so much, Marius. Thank you so much, Timo. So basically, if there is one takeaway that I want to make sure that you get out of this session with, if there is one thing that I would love that you remember of this summit, data is becoming a key differentiator between the different manufacturers. And AWS can definitely help you accelerate your digital transformation to be a data-driven, software-driven manufacturer. Thank you so much, Timo. Thank you so much, Marius. And I wish you an excellent rest of the day at this summit. Thank you very much.